Namaste. This is JVN Dr. Vishal Saxena, Associate Professor in Mathematics in Jayoti Vidyapeeth Women's University, Jaipur. Today we are going to discuss on the module expected value of perfect information. Expected value of perfect information, which is also known as EVPI. This module, this session is a part of the course Operation Research and belongs to the program of BBA 6th semester and BBA LLB 6th semester of the university. The today's session of EVPI, that means the expected value of perfect information, is an important topic of subject operation research and the decision theory. And as all we know that the decision theory is a model in the operation research, and it deals with the various techniques for finding the best decision making or the best decision option by the decision maker in the various conditions, in the favorable or in the unfavorable conditions. Operation research subject just consists of various models and it will provide the decision help for the decision maker in the various conditions by the different models, for example game theory and linear programming model, the replacement model and assignment transportation models and many more. So the decision theory is a very important part of the operation research, is a very important model, and the today's session is the part of this subject, the expected value of perfect information, EVPI, and in the today's session we are discussing about that, how to find and what is meaning of this topic, expected value of perfect information. The expected value of perfect information can be taken as the price that one would be willing to pay in order to get or to access the perfect information. Just it can be taken as a price and just price for the finding of the perfect information or the right and the complete information just for any event. And this, as all we know that every event, just every decision is consists of the uncertainty. So when a decision maker makes some decision, then uncertainty is always related with the decision, and in the absence of the perfect information. If the decision maker has the perfect information, has a proper and complete information, then his decision can be considered as the proper and the perfect decision. Otherwise, just uncertainty is always related with his or her decision. And this topic, this session of expected value of perfect information, that means EVPI, just will measure the expected cost of this uncertainty. So now we are having some slides to explain this topic with more information and with more just mathematical concept, notations and examples. So now we share some slides. These slides are important, and this will explain the whole concept of this session. So now we take these slides, and initially the expected value of perfect information is defined in this first slide, and we can just see in the decision theory the expected value of perfect information can be just defined as the price that one would be willing to pay in order to gain or to access to perfect information. And a commonly discipline that uses the EVPI concept is the health economics. So one of the field is given that the health economics, where this EVPI is very much required, because in that context, and when looking at a decision of whether to adopt a new treatment technology, there is always some degree of uncertainty surrounding the decision. So just a kind of uncertainty is always related with the decision in the health economics, and therefore the concept of EVPI is very much useful for this. So the expected value of the perfect information analysis tries to measure the expected cost of that uncertainty. So just it will explain, it will try to measure the expected cost of that uncertainty, and it is very important in health economics. And this can be interpreted as the expected value of perfect information, since perfect information can eliminate the possibility of making the wrong decision, at least from the theoretical perspective. So just when a decision maker will have the complete information, then the chances of his decision to be wrong are almost negligible, almost very small. Therefore the decision maker will make a proper and the right decision, at least we can say in the perspective of the theory. And therefore the concept of EVPI, the perfect expected value of perfect information, is very much important there. And now we just explain this EVPI with this example. And here in this example we are given that a group of students raise money each year by selling souvenirs outside the stadium of a cricket match between the teams A and B. So in this question there are several students, some students and a group of students raise the money, and raise money every year by selling souvenirs outside the stadium of a cricket match, and the cricket match just played between the two teams A and B. They can buy any of the three different types of souvenirs from a supplier, and their sales are mostly dependent on which team wins the match. So when the students buy their souvenirs by the supplier, so there are just the three types of souvenirs are there for the students, but their just profit and the sales are mostly dependent on which team wins the match. That concept. A conditional payoff in rupees table is as under. So in this table for the question we are having the payoffs for the team A and B on winnings. So when the team A wins and when the team B wins, so we are having the payoffs, and for the three different type of souvenirs 1, 2 and 3. And according to question, what is just needed to find, first point, the construct the opportunity loss table, and in the second point, which type of souvenir should the students buy if the probability of team A's winning is 0.6, and third is the point for the computation, the cost of the uncertainty. So in this question we are required the three of the important parts of this concept of just decision theory. One is the opportunity loss table, and Second is just we have to find here which type of the souvenir should the students buy, and it will be based on the concept of probability. And the third is the cost of the uncertainty. So here now we start to solve the question, and first we can make the opportunity loss table, and the opportunity loss table can be seen here. How it is formed? So just we can see there actions and the events are written there. Events are winning of team A and winning of team B, and the actions are from the type of souvenirs bought 1, 2 and 3. And the opportunity loss table, opportunity loss can be just obtained by the just subtracting the payoff by the highest payoff for the particular particular action for the team A or the team B individually, that means for the row. So we can see for the team A wins the 1200 is the maximum payoff, and now we are subtracting payoffs from this maximum, this highest payoffs. So 1200 minus 1200 is equal to 0, and 1200 minus 800 is 400, and 1200 minus 300 is 900. So in this way these are the just opportunity loss for the team A, while for the team B these are given by 850, 400 and 0, and these are obtained by the usual process just explained for the team A. The second point is required for the expected opportunity loss. So the expected opportunity loss for the buying of the type 1 souvenir, and that is given by 0 into 0.6. 0.6 is the probability there, and 0 is the payoff for this first type of the souvenir for the team A, plus 850 into 0.4, and 0.4 is the probability, and 850 is the payoff for this winning of team B under this first type of souvenir. So in this way this expected opportunity loss EOL is given by 340, and 340 is the expected opportunity loss, and in the same way for the second souvenir, for the third souvenir, the expected opportunity loss can be obtained, can be determined, and these are coming 400 and 540. Since the EOL of buying type 1 souvenir is minimum, so expected opportunity loss of buying type 1 souvenir is minimum, therefore the optimal decision is to buy type 1 souvenir, and we can just observe that the optimal decision for buying the type this type 1 is the best optimal decision. And in the third part where just cost of uncertainty is required, so cost of uncertainty can be given by EOL of the opportunity action, so expected opportunity loss, and that is just given there 340. So it is 340 is the cost of uncertainty. And we have discussed today about the expected value of perfect information, and we have just seen in the today's session that how important this topic is. So this topic is a very important topic for for the perfect decision, and it can be just determined with the concept of expected opportunity loss, and we have explained that with examples. So now students are advised to prepare this topic with concepts and solve some more numerical problems for commanding over this topic, and prepare objective as well as subjective question for examinations and for the competitive examinations. Thank you.